Our atmosphere, that thin, glowing, and seemingly fragile layer that astronauts see from outer space protecting the Earth, is one of the main reasons why life exists here in our planet. Aside from its necessary role in photosynthesis and respiration, this mixture of gases is mostly responsible for a suitable climate, allowing different ecosystems to thrive. Of course, it's the Earth's sweet distance from the sun that makes us enjoy ample sunlight. But if that's the case alone, the temperature on the Earth's surface would drop significantly during nighttime. Imagine this: without an atmosphere, marine life would cease to exist because oceans and all water forms would be freezing at an average surface temperature of negative 18 degrees Celsius. So how does our atmosphere retain heat all day and all year round? You might have heard of an analogy that goes something like this. The Earth is like living inside a huge greenhouse, and our atmosphere is responsible for trapping the heat inside, creating a heat flow because of the density differences between the warm air by the surface and cool air in the atmosphere. Well, that is not accurate. The only similarity between a gardener's greenhouse and the atmosphere is that they both allow most of the solar radiation to pass through to be taken in by the organisms living within it. See, not all sunlight is absorbed by the Earth. Some parts of the damaging UV rays are blocked by the atmosphere and is reflected back to space. The long infrared waves are consumed by the clouds and the atmosphere itself, and a huge chunk of visible light is absorbed by the oceans, land, vegetation, and other species on the Earth's surface. This consumed energy by the surface is then converted into heat and re-emits it in our lower atmosphere in the form of infrared radiation. Now, this is where the difference lies. Unlike a greenhouse where the air inside is warmed up due to convection, it is the capacity of certain molecules to absorb photons from infrared radiation that makes the heat circulate in our lower atmosphere. Gases like carbon dioxide, water vapor, methane, and nitrous oxide are made up of molecules that exhibit this ability, dubbing them the greenhouse gases. These molecules are composed of more than two atoms bound loosely together that vibrates upon absorbing energy, then re-emits that same energy to be drawn in by another greenhouse molecule. This chaotic heat ping-pong between molecules is the concept behind the greenhouse effect, giving our atmosphere the capability to support our complex biosphere and making the Earth one suitable planet to live. This video is part of the Green Chemistry series of this channel. Want to learn more or suggest some topics? Click on the subscribe button, leave a comment below, or follow us on social media for more updates.